Hello, welcome to the video where I'm going to show you how you can fit models to individual growth curves. And in this video, we're going to be using the Fit button down here. So you can fit a variety of different models to these data sets. When you click this button, you can choose a flat line, a linear, quadratic, exponential, or the thing that I'm going to first talk about, which I think is most relevant and useful in ADA, the Zweitering et al. Model. So this model was published in 1990 in a paper where they compared different models for predicting bacterial growth and came out with their superior one. And this has been used a lot and is still being used in microbiology experiments. It's a good model because it can tell you, it can predict for you how much biomass you get, what your growth rate is, because it takes in the whole curve, not just the exponential point, the point where you're exponential in log. It can tell you how long your lag is and different parameters. So it's really useful, and I think I especially like to use it for the correlation plots function in ADA, which I've discussed in another video, so please do check that out if you're interested. So I'm first going to show you how well the fit is with the Zweitering model onto some of my data. So I'm going to choose this blue line to fit first. I'm going to pick the Zweitering model. I'm going to pick the whole duration of the experiment. If you want, you can also select this if you already know some of the parameter bounds of your experiment. So if you know your starting absorbance, what your biomass would be at the start, and so on, to make your model even more accurate, you can fill that out. I'm not going to bother in this example. I select fit, and you can see it's a very nice snug fit for my data. So this is spirulina plot, so it works with filamentous cyanobacteria. I've also tried this with chlorella and chlamydia plots, and again, you get really nice fits. But sometimes this, for example, this growth here is a bit strange because it started really dying off. So I have noticed when I fit this one across the whole duration of my experiment, I don't get quite so nice a fit. But if you have that problem, that didn't work at all. What did I do? If you have this problem, it's because I was trying to fit a flat line. What you can do is try and get it to fit better by changing the time point. So it's sort of, the model is surprised it managed to shoot off like this. I'm not surprised because I knew what I was doing, which was growing it under extremely high light intensity. So here you might just want to change your parameter slightly. So do, for example, 0 to, I don't know, 4 days. And you can see that fits nicely. So bear that in mind, if you're using your correlation function, the model isn't always going to be accurate with some of them, so you need to just check that. Check that it's a nice fit for all of them before making assumptions such as growth rate and biomass using this model. So if you want to also see how well this fits and some of the parameters that you can get in the two-table function, which I've discussed in another video, so you can use this function to do these sort of types of fit in parallel for all of your growth curves at once instead of individually, how I've done it here. You need to go to your Stats tab and select Show Fit Model Text, Show Fit Parameters, and if you want, you can also show fit errors. And if your significant figures are too low for this, so you can't distinguish between them, just up them. Normally up them to about 4. Now here you can see it's spat out for me, and you can drag these as well. It spat out for me what these different things were. So for example, this is the growth rate, this symbol. And one of these is lag, one of these is biomass. So you can, get information quite quickly out of that. Okay, and I'm just going to quickly show you can fit other models as well. So if you just click the fit button to make it go away, click it again, So, for example, if you want, you can model exponential growth, how well it fits to an exponential line. So let's do the orange growth curve from 0 to 4. It shows you how well the fit is. Another example, I could do a linear one if I wanted. Let's do this sort of blue one between, I don't know, days 3 and 5. And so on. And yeah, if you so want, you could do the flat line to show that this is basically, that's the best fit for this line here, which is my one at the bottom. There you go. Okay, so I hope you find that helpful. Like I said, if you want to do all of this in parallel and get all of these different parameters, you have to use the two-table function. Thank you.